Hi, welcome to the Excel for Statistics class. This course teaches you statistical thinking concepts that are essential for learning from data and for making business decisions. By the end of the course, I hope you will be able to perform basic statistics analysis using Microsoft Excel. In this meeting, we will learn some statistical functions that can be used in Microsoft Excel. Functions are predefined formula that perform calculations by using specific values, called arguments or structure. Functions can be used to perform simple or complex calculations. The Excel functions that we will learn in this meeting are okay. So there are 12 functions that we will learn in this meeting. The first one is forecast linear. The second one is intercept. The third one is Linus. Number 4 is slope. Number 5 is trend. Number 6 is growth. Number 7 is losses. Number 8 is stakes. Number 9 is beta distribution. Number 10 is binomial disk. Number 11 is binomial disk range. Number 12 is binomial INV. Okay, from these 12 functions, we can break it down into two type of function. So from the forecast linear until the stakes, it's the trend line function. And then from beta this until binomial this in INV, it is distribution and test of probability type of function. Okay, so we are going through to the first function, forecast linear. So, okay, so forecast linear is a function used to calculate or predict future values using existing values. Okay, so it will be used to calculate the future values using the existing values. And then the syntax of the function is equal forecast linear, and the item are x, known y, known x. So the x is the data point for which you want to predict a value. And then the known y is dependent array or range of data. And then the known x is independent array or range of data. So we have this data set. I need you to type the dataset first, and you can pause the video. After you finish the dataset, you can play this video again. Okay, I hope you already finished the dataset. Okay, so we have the information for y and x, and then for the x. Okay, so for the x, I choose 2 to fill the x information, but you can change it into the other number. This is just for the example only. Okay, so to do the forecast linear function, we type equal forecast linear, open the bracket, and then we put the x in here, and then semicolon, the known y, we put the array, we block from 4 until 30, semicolon, and then the known x, we block it from 1 until 7. We close the bracket. So the future values from the x2 is 9.642857 watt. So this is the forecast linear function, how to perform the forecast linear function. Okay, the next one. Let me delete this one first. Okay, the next one is intercept function. Intercept function is a function used to calculate the point where a line will intersect the y-axis using the x value and y value. The syntax of the function is equal intercept. The item is known y and known x. For the known y is the unit of observation or dependent data. For known x is the unit of observation or independent data. So the y is dependent, and then for the x is independent. And we have this kind of information. I think it's the same with the forecast linear. So you can copy the dataset from the forecast linear and put it in a new sheet. Okay, so we will perform the intercept function from now. So how to perform the intercept function? Put equal intercept, open the bracket, and then for the known y, we put range from 4 until 30, and then for put semicolon symbol, and then for the known x, we put the range from 1 until 7. Close the bracket and enter. So the intercept from this data set is 0.71428571, around that number. So this is the intercept function. Okay, so I hope you already know how to perform the forecast linear function and then the intercept function. And to the next, we have Linus. I'm sorry. Okay, so we have Linus function. Okay, so the Linus function is a function used to determine the parameter of the exponential trend. The syntax of the function, the Linus function, is equal Linus, and then the item are known y, known x, const, and stats. Okay, so for the required one is only the known y. Okay, so for the known y is the set of y values that you already know in the relationship of y equal mx plus b. And then for known x is a set of x values that you may already know in the relationship of y equal mx plus b. For the const is a logical value specifying whether to force the constant b to equal 0. And then for the stats is a logical value specifying whether to return additional regression statistics. Okay. So for the data set, it is different from from before. So you may type the data set first, and you can pause the video after you finish the data set and the table. You can play this video again. Okay, I hope you already finished your data set and the table. So we have known y and known x information in here, and then we have const table and stats table and then Linus table. Okay, so for the const table, because const and stats, it's a logical value. So I just type true. For the cons, you can choose false if you want. But for the example, we will use true. And then for the stats, I want to put false in here. Okay, so for the line to perform the Linus function, we put equal Linus, open the bracket, put the known y. Okay, the range from 1 until 7, and then semicolon. The known x range from 24 until 81. Then we put cons true, and we put false. Okay, and then we close the bracket, and the result is 0.09703 This is the parameters of the exponential trend from this data set. You can change the data set, and you can change the cons and stats logical value. You can do it by yourself, I think. Okay, so we move into the next function. Next function is slope function. Slope is a function used to find the slope of a linear regression line through data points in known y and known x. Okay, so slope is a function that used to find the slope of a linear regression line. The syntax of the function is equal slope, known y, the item is known y and known x. For the known y is an array or cell range of numeric dependent data points, and then for the known x is the set of independent data points. So we have the new data set in here. You may type the data set first and make the table, and you can pause the video. After you finish the data set and the table, you can play this video again. Okay, so I hope you already finished your data set. And then we have y information that of y data set, and then x data set, and then the slope table. Okay, so how to perform the slope function? We put equal slope, open the bracket, known y, put the range from the 1/4/50 until 1/6/50, put the semicolon, and put the range from 8 until 10. Close the bracket and enter. So the slope of a linear regression from this data set is minus 3.2748756. Okay, you may change the data set. It will be resulting with different result. Okay, different answer, but yeah, you can try it by yourself. Okay, the next one is trend function. Okay, trend is a function used to find values along a linear trend. Okay, so trend is a function used to find values along a linear trend. The syntax of the function is equal trend, non y, non x, mu x, and cons. So for the known y, it's a set of y values you already know in the relationship of y equal mx plus b. For the known x, it is optional. An optional set of x values that you may already know in the relationship y equal mx plus b. For the new x, it's optional too. The new x values for which you want trend to return corresponding y values. And then for the cons is a logical value specifying whether it will force the constant b to equal 0. Okay, so we have this data set. You might type the data set first. You can pause the video. After you finish it, you can play this video again. Okay, So I hope you already finished your data set. So we have the information of y, x, and the new x. Okay. So for the cons, because it's a logical value, maybe I just type true in here. Okay. So how to perform the for the new x, I put 100 in here. You may change the number, but for the example, for now, I will use 100. Okay, so to perform the trend, we put equal trend, open the bracket, put the range of known y's from 10 until 90, and then semicolon, and then put the range of known x from 11 until 71, semicolon, put the new x number, 100, semicolon, put the cons, the true, close the bracket. So the result of the trend is for the new x, the 100. Okay, the trend or the values from the linear is 109.5068875, around that number. Okay, so it's around 109. So I hope you already know how to do the Linus slope and trend. You can change the new x number and try it by yourself. Okay, the next one is growth. Okay, growth is the function used to calculate exponential growth prediction using existing data. So it is used to calculate exponential growth. The syntax of the function is growth equal growth, known y, known x, new x, and cons. So in some of the functions from growth, trend, and slope, we always see known y, known x, new x, and cons. Okay, so it's maybe a pretty same, but with different meaning for these items. Okay, so we have this data set. Okay, you may finish the data set first, type the data set first in your sheet, and then you can pause the video, and then after you finish the data set, you can play this video again. Okay, I hope you already finished your data set. We have month information and then income information. And then for the new X, I put 10 in here. Okay, so no problem. There's no problem with that. So to do the growth function, we must put the cons. I just put true in here. You may put false or change the X number. That doesn't matter. So how to perform the growth? Equal growth, open the bracket, and then the known y. For the known y, we put the range from the month column, and then semicolon. For the known x, we put income information, and then the new x, we put 10, and then for the cons, we put true. The result is 22.36238.1 for this kind of data set. So this is the growth function. The next one is the logis function. What is logis function? Logis function is used to calculate an exponential curve that fits your data and returns an array of values that describe the curve. The syntax of the function is equal logis, and the item is known y's, known x, cons, and stats. Okay, so it's basically it's pretty the same with the previous function. So we just go through this new data set first. Okay, so this is the new data set, I think. Okay, it's the same with the Linus. Okay, so you can put the Linus data set into the new sheet, and then we can perform the logis function. Okay, so to perform the logis function, we put equal of logis, open the bracket. For the non-wise, we put the range from, 24 until 81, semicolon, the range for x from 1 until 7, and then, oh, so we don't have cons and stats in here, so we just put, just close the bracket because the non-x cons and stats are optional, and the required one is non-wise. Okay, so we put the enter in here, and then we have the result of the logis function from this dataset is 1.22733627 and so on. Okay, so the exponential curve with that fit with this kind of dataset is 1.2. Okay, so we go to the stakes. Okay, stakes is a function used to determine the standard error of the estimated y value for each x value in the regression. The syntax of the function is equal stakes, non-y's, and non-x. Okay, so for the non-y is the dependent array or range of data points, and for the non-x is independent array or range of data points. And then we have this kind of data set. You may type the data set first, and after you finish it, you can pause the video, and after you finish it, you can play this video again. Okay, so I assume you already finished your data set. So we have a y column, x column, and then the stakes table. Okay, so to perform the stakes function, we put equal stakes, open the bracket, non-wise, put the range from 4 until 10, semicolon from the 6 until 3, the range from 40 known x. Close the bracket, and then the result from this text function for this data set is 2.963 and so on. Okay, so this is the stakes function. We use it to determine the standard error. Okay, so the next one is beta distribution. Okay, so beta distribution or the beta dis is a function used to calculate the beta distribution. The syntax of the function is equal beta to this x. The item are x, alpha, beta, cumulative a and b. Okay, for the x is the value between a and b at which to evaluate the function. For the alpha is a parameter of distribution, and for the beta is parameter of the distribution. The same with alpha and beta is the same meaning. And then cumulative is a logical value that determines the form of the function. And then for the a is a lower bound to the interval of x. And then for the b is an upper bound to the interval of x. Okay, so I just put the table that have information for the item that we already learned in here. So you may make this table first, and you can pause the video. After you finish the table, you can play the video again. Okay, so I hope you already finished the table. So for the value at which to evaluate the function or x, we can say it was x. I put 3 in here. You may change the number. And then for the parameter of distribution, for alpha, I put 7 in here. You may change it. And then for the parameter of distribution or beta, I put 9. And then for the cumulative, because it is a logical value, I put true in here. You can change it. You may change it into false. And then for the lower bound, I put 1. And for the upper bound, I put 4. Okay. So when you have when you have statistic information and you want to do the beta distribution function, you may just make the table like this one and then put it into the beta dis function. Okay, how to perform the beta distribution function? We put equal beta dis. Okay, and then the x, we put the x 3, we put the alpha 7, we put in the beta 9, we put the cumulative through, we put the lower bound 1, and we put the upper bound 4. And then the result is 0.96 and so on. So this is the example how to perform the beta distribution function. And then the next one is binomial distribution. So binomial is the function used to determine the probability distribution of individual binomials. So the syntax of the function of binomial this is equal binom.this, and then the item is numbers, trials, probability, and cumulative. So for the number is the number of success in trial, and then for trial is the number of independent trials. For the probability is the probability of success on each trial, and then for the cumulative is a logical value that determines the form of the function. Okay, so for the dataset, we have a new dataset. You may make the dataset first. You can pause the video, and after you finish the video, you can play the video again. Okay, so I hope you already finished your dataset. So we have argument information in here and data information. So for the number, I put 7, and then for the trials I put 9, and then for the probability I put 0.5, and then for the cumulative I put false in here. You may change the number and change the cumulative. There's no problem in there, but for now we will use this example. Okay, so how to be the binomial distribution function? We put equal binom is, open the bracket, put the number 7, put the trials 9, put the probability 0.5, and put the cumulative false. Close the bracket, and the result is 0.07 and so on. So this is the result of the binomial distribution function. Okay, and the next one we will learn about the binomial distribution range function. I'm sorry. Okay, so for the binomial distribution range is the function used to determine the probability of an experiment using the binomial distribution. The syntax of the function is binomial distribution range, trials, probabilities, numbers, and numbers too. Okay, so for the trial, probability, and numbers, it is required, but for the numbers two in here, it is optional. Okay, so we have this kind of data set. You may make this data set first, and you can pause the video. After you finish the data set, you can play this video again. Okay, so I hope you already finished your data set. So we have trials, probability, numbers, and numbers too. Okay, so for the trials, I put 40 in here, and then for the probability, I put 0.5, and then for the number, I put 25, and then for the numbers too, I put 30. Okay, it is subject to change. You can change it, so there's no problem with that. And then to perform the binomial distribution range, we put equal binomial range, and then put the trials number 40, the probability 0.5, the number 25, and then the number 2 is 30. Close the bracket, enter. The result is 0.076 and so on. So this is the binomial distribution range function. And then the last one for this meeting is binomial INV. Binomial INV function that is used to find out the smallest value where the cumulative binomial distribution is greater than or equal to the criterion value. The syntax of a function is, so the argument is trials, probability, and alpha. So for the trials, it's the number of Bernoulli trials, and then for the probability is the probability of a success on each trial, and then for the alpha is the criterion value. Okay, so this is the data set for the binomial INV function. You may put the data set first, type the data set first, and you can pause the video, and after you finish it, you can play this video again. Okay, so I hope you already finished your data set. So for the binomial INV, if you have already have the information, you can just put it into these tables. But if you don't have any information yet, so I give you an example. So for the trials, I put 5 in here. For the probability, I put 0.25. And then for the alpha, I put 0.5. Okay, so let's perform the binomial INV function. So for to perform the binomial INV, we put equal binom INV, open the bracket. For the trials, I put 5 in here, and then the probability 0.25, and for the alpha 0.5, close the bracket and enter. So the result of the binomial INV is 1 for this data set. You may change it into the other number for the data set, but for now we will use this set of number for the example. Okay, so I think that's all for this meeting. So I hope you already learned about how to do the trend line function, and then the distribution and test of probability function. Okay, so I think that's all for now, and then I hope you learn a lot, and it helps you to your journey to learn the statistics for Excel for statistics. Okay, so see you in the next meeting. Goodbye.